y equals to negative 3x square negative 58, y equals to px negative 46. In the given system of equations, p is a constant. The graphs of the equations in the given system intersect at exactly one point x comma y in the xy plane. Which of the following could be the value of x? Okay, using the given information, we have to find the value of x. Actually, this x is the x coordinate at the point of intersection of the graphs of given two equations. Okay, to get the x coordinate or y coordinate at the point of intersection of the two graphs, what we have to do is we have to solve the given system of equations. We can set y equals to y to solve the given system. For the y on the left side, we can consider the stuff with the second equation, that is px negative 46. For y on the right side, we can consider the stuff in the first equation, that is negative 3x square negative 58. Here we have a quadratic equation. Let's write this quadratic equation standard form, that is ax square positive bx positive c equals to 0. We have everything on one side of the equation, on the other side we have 0. Okay, let me make the right side 0 over here. Let me add 3x square to both sides of the equation, and also add 58 to both sides of the equation. Let me do it. Okay, negative 3x square positive 3x square will cancel out. Negative 58 positive 58 will cancel out. We get 3x square positive px. And when I combine negative 46 and positive 58, I am getting positive 12. On the right side, we have 0. Here I got a quadratic equation in standard form. And the question says the graphs of the given two equations intersect at exactly one point. Since the graphs intersect at exactly one point, when I solve the given system of equations, I'll be getting one solution. That is, I'll be getting only one value for x over here. And I got this quadratic equation by solving the given system. Since the given system has only one solution, solving this quadratic equation will be getting one solution. That is, I will be getting only one value for x. Now let me consider a quadratic equation standard form, that is ax square positive bx positive c equals to 0. The maximum number of solutions we can have for a quadratic equation is 2, because the degree is 2. Sometimes we'll be getting only one solution for a quadratic equation. Sometimes we'll be getting no solution. Okay, when we have a quadratic equation standard form, that is in the form ax square positive bx positive c equals to 0, and the quadratic equation has only one solution, then the value of the discriminant b square into 4ac will be equal to 0. Okay, since this quadratic equation has only one solution, the value of the discriminant b square into 4ac for this quadratic equation will be 0. Actually, to get the value of b, we have to consider the coefficient of x, and to get the value of a, we have to consider the coefficient of x square, and to get the value of c, we have to consider the constant term. Here the coefficient of x is p, so then we have to take p square negative 4a. For a we have 3, and for c we have 12 equals to 0. Okay, p square negative 4 times 3 is 12, 12 times 12 is 144 equals to 0. Okay, let me continue over here. P square negative 144 equals to 0. Let's solve for p in this equation. Let me add 144 to both sides of the equation. Then negative 144 positive 144 will cancel out. I'm getting p square equals to 0 positive 144 is 144. Now to solve for p, we have to get rid of this exponent 2. Let me take a square root on both sides of this equation to get rid of this square. Okay, here the square root and square will cancel out. Usually when we take square root on both sides of an equation, one of the square roots will cancel out, like what happened over here on the left side. And for the other square root, we have to consider positive or negative sign. Then we get p equals to positive or negative. Square root of 144 is 12. Okay, we get two values for p. One is positive 12 and the other one is negative 12. Okay, now let's consider the first equation we have over here. Actually, it is a quadratic function and its graph will be a vertical parabola. Whenever we have a quadratic function in this form, y equals to ax square positive bx positive c, then we'll be getting a vertical parabola as a graph for this one. And here we have to consider the leading coefficient, that is the coefficient of x square. So that's the value of a. When a is greater than 0, then the parabola we get for this quadratic function will open up. If a is less than 0, then it will open down. Okay, here in this quadratic function, the leading coefficient is negative 3, which is negative. So the parabola, the vertical parabola we get for this one will open down. So this is the graph for the first one. And the second one is a linear equation. It's in slope Petersen form. That is in the form of y equals to mx positive b. Here m is the slope. At the place of m we have p. So here in the second linear equation, this p represents the slope. We got two values for p. One is 12 and other one is negative 12. When I consider the positive value 12 for p over here, I will be getting a rising line because the slope is positive. So rising line means like we'll have a line like this. And also the line we are getting for the second equation and the parabola we are getting for the first equation will intersect at only one point according to the given information. Okay, here this is the point of intersection of the graphs of two equations. What if I consider the negative value for p, that is negative 12, then the slope will be negative, then we'll be getting a falling line like this. In that case also, both the graphs will intersect at only one point. But both the values of p are not possible. Only one of the values for p is not possible because I will be getting one straight line for the second equation. It may be rising or falling. It depends on the value of p. Okay, so we can consider only one of the values for p. Anyways, let's consider the first value of p 12. Now what I'm going to do is I'm going to plug in the first value of p in the quadratic equation over here. Let me do it. 3x square positive 12x positive 12 equals to 0. Okay, when I consider the second value of p, that is negative 12, then this quadratic equation will become 3x square negative 12x positive 12 equals to 0. When I consider the terms of both the quadratic equations, each term is a multiple of 3. So we can divide all the terms of the first quadratic equation by 3 to simplify this one. Okay, let me do it. Okay, here 3. Okay, this 3 will cancel out. I'm getting x square. When I divide 12x by 3, I'm getting 4x. When I divide 12 by 3, I'm getting 4. On the right side, 0 divided by 3 is 0. Okay, I think we can solve this quadratic equation by factoring. For that, we have to multiply the constant of positive 4 by the coefficient of x square 1. 1 times positive 4 is positive 4. Now we have to get two factors over here so that the product of two factors equals to positive 4 and the sum of the two factors equals to the coefficient of x, that is positive 4. I think positive 2 and positive 2 will work. When I multiply positive 2 and positive 2, that is equal to positive 4. When we add them, that is equal to the coefficient of x or positive 4. Further, we have to divide both the factors by the coefficient of x square 1. Even when I divide them by 1, still I'm getting positive 2 and positive 2. Since we got the two same factors over here, we'll be getting one solution for the quadratic equation over here. There is only one value for x. Okay, to get that value of x, we have to change the sign of the factor over here. It's already positive 2. When I change the sign, it will be negative 2. Okay, in this quadratic equation, I got x equals to negative 2. Now, let's do the same thing for this quadratic equation. Here in this one also, each term is a multiple of 3. Let me divide each term of this quadratic equation by 3. Okay, this 3 will cancel out. I'm getting x square negative 4x positive 4 equals to 0. Let's solve this one by factoring. Let's multiply this constant of positive 4 by the coefficient of x square 1. Then I'm getting positive 4. Okay, we can take the factors negative 2 and negative 2. When we multiply negative 2 and negative 2, I'm getting positive 4. When we add them, that is equal to the coefficient of x, negative 4. Let's divide both the factors by the coefficient of x square 1. Then we get negative 2, negative 2. Okay, here we got two same factors. I'll be getting only one value for x in this quadratic equation. To get that one value, we have to change the sign of this factor. It's negative 2. When I change the sign, it will be positive 2. Okay, here I got two values for x. One is x equals to negative 2 and the other one is x equals to positive 2. Since we got two values for p, here we get two values for x. Already we have discussed among the two values of p over here, only one of them is possible, not both the values. Since only one of the values of p is possible, in these two values of x, only one is possible. Either x equals to negative 2 or x equals to positive 2, not both the values. Okay, when I go over the answer choices, I find this negative 2 in answer choice A. So among the values we have for x in the given answer choices, negative 2 could be the value of x. The correct answer choice for this question is A.